Today we're going to begin our discussion on complex numbers. So to begin, let's think about what a square root is. If I had the square root of 16, I could say the square root of 16 is 4 because 4 times 4 gives you 16. Or if I had the square root of 100, the square root of 100 is 10 because 10 times 10 gives you 100. Well, if I had the square root of -1, that doesn't have a square root. There's no real solution to that because there's no number where you can multiply it by itself to give you a negative number. So you can't take the square root of negatives. So it says in the set of real numbers, negative numbers do not have square roots. You can't do that. So we want to be able to take the square root of that. So we call that an imaginary number. It says imaginary numbers were invented so that negative numbers would have square roots and certain equations would have solutions. So since we can't take the square root of -1, we're going to call that an imaginary number, and we're going to use I to represent that. So I is going to equal the square root of -1, which means that I squared equals -1. So today we're going to use the imaginary number in solving equations. So if we look at example 1 says x squared minus 16 equals 0, and our directions say that we want to solve this. So if we're going to solve, just like we would any normal equation, we're going to add 16 here first. So that says that x squared equals 16. Well, we want to solve for x. So to get this x by itself, we're going to take the square root of each side here now. So the square root of x squared becomes x, and the square root of 16 is 4. Well, when we factored, when we were solving equations, we said, well, each one of these has to have 2 answers since we have this exponent of 2. So we know 4 times 4 is 16, but -4 times -4 is also 16. So we're going to say x equals positive or -4. We're going to use that symbol. That means that one of our answers is +4 and one of our answers is -4. So if we look at example 2, we have x squared plus 16 equals 0. So similar to this first one, but here we're going to subtract 16. We're going to say x squared equals 0 minus 16 is -16. Then we're going to take the square root. So the square root of x squared is x. Well, square root of -16, we can't take the square root of a negative number. But we can say this is the same thing as the square root of -1 times 16. Well, in the first slide there, we said the square root of a -1, we can't do that, so we're going to call that an imaginary number. So we're going to say x is equal to I times the square root of 16. That I gets rid of this -1 here. Now we can say the square root of 16 is 4, positive or negative, just like we had on example 1. We're just going to bring down the I beside it. So notice how these answers are similar. Here, the square root of a positive number gave us 4. Here, the square root of the positive 16 gave us this positive 4. But we brought down this I because of this negative number. Okay, so we're still going to continue to solve these equations. So example 3 says 5y squared equals -40. So first thing we'll do here is divide by this 5. So that way that will cancel. So I have y squared equals -40 divided by 5 is -8. We're trying to get the y by itself, so we're going to take the square root. Square root of y squared is just y. Okay, and here we can't take the square root of a negative number, but we said this is the same thing as saying -1 times 8. Well, if we write it that way, then we can say the square root of -1, we can call that I and leave the square root 8 part. Now the square root of 8, that's not a perfect square. We can't take the square root of 8. But we can do our factor tree here. We can say, what can we multiply together to give us 8? Which would be 2 times 4. We can break down this 4 into 2 times 2. We'll carry that 2 down. So we have a pair of 2's with the 2 left over. So we'll say y equals, the pair of 2's comes out, plus or minus in the front. We're going to bring down this I beside the 2. And then whatever's left over, which is this 2 we have underlined, goes underneath your square root sign. So y equals plus or minus 2i times the square root of 2. Okay, so example 4, we have r squared minus 4 equals negative 8. So we'll add 4 to each side first. So we get r squared equals, so negative 8 plus 4 is negative 4. Now we want to get that r by itself. So we're going to take the square root here. So the square root of r squared, square root of negative 4. So the square root of r squared is r. Same thing here. We can't take the square root of a negative, but that's the same thing as negative 1 times 4. So the square root of negative 1 becomes I. We'll leave that square root 4. We can take the square root of 4, which is 2. So this becomes plus or minus 2, and then bring down the I beside it. Example 5, we have y squared plus 25 equals 0. So we're going to solve for y, so we'll subtract 25 first. So y squared equals 0 minus 25 is negative 25. You're trying to take the square root because you're trying to solve for y. So square root of y squared is y. Same thing here, you can't take the square root of a negative. So, but that's the same thing as negative 1 times 25. Now you can say the square root of 25, well that's 5, plus or minus, and the square root of negative 1, that becomes I. So y equals plus or minus 5i. And then example 6, we have 3x squared plus 1 equals negative 35. So we'll subtract 1. So 3x squared, negative 35 minus 1 is negative 36. Divide by 3. So x squared equals negative 36 divided by 3 is negative 12. It's supposed to be a 12 there. Okay, and then we want to take the square root. The square root of x squared becomes x. Square root of negative 12. So we can't take a square root of a negative, so that becomes our I, which will leave that as square root 12. Can't take the square root of 12, that's not a perfect square, so we have to do our factor tree again. So I'm going to say 4 times 3 will give me 12. I can break down 4 into 2 times 2. Can't break down the 3. We have a pair of 2's with a 3 left over. So x equals, pair of 2's goes on the outside with our plus or minus in front. I'm going to bring down my I right beside my 2, and then what's left over goes underneath the square root sign, which is 3. So x equals plus or minus 2i times the square root of 3. So last two examples, we have 4 plus 25y squared equals 0. So I'm going to subtract 4. So 25y squared, 0 minus 4 is negative 4. Then I'm going to divide by 25. So y squared equals, well 25 doesn't go into 4. I'm going to leave that as negative 4 over 25. So I'll have my fraction here. Then I'm going to take the square root. So the square root of y squared is y. Now notice this is a negative, so once again we can't take the square root of a negative. So that's our I, and then this will become positive 4 over 25. That we can take the square root of. So y equals, take the square root of the numerator, which is 4. So square root of 4 is 2. Square root of 25 is 5 with our plus or minus out front, and then we'll just carry our I down beside it. Okay, and then example 8, we have 36x squared plus 49 equals 0. So this one's similar to example 7. So we'll subtract our 49 first. So that way that will cancel. So we'll get 36x squared. 0 minus 49 is negative 49. Divide by 36. So x squared equals, 36 won't go into 49 evenly, so I'm just going to leave that. Negative 49 over 36. Okay, now we want to get the x by itself, so we'll take the square root of each side. So x equals, so just like the last one, we can't take the square root of that negative. We can take the square root of 49, which is 7. We can take the square root of 36, which is 6, our plus and minus out in front. But the square root of this negative, that becomes our I. So x equals plus or minus 7/6 I.